Hi, this is Thomas. Welcome to math class. Today we're going to look at polynomials. We'll start by creating a cubic function with 3 given zeros, and then once we have our cubic, we'll look at additional analysis that we might be requested to do for a given cubic function. So let's start with 3 zeros. If we're given the 3 zeros, -4, -1, and 3, and asked to, with these zeros, create the cubic function, then what we have is we're going to have the following factors. X plus 4 is the factor that produces the 0 of -4, times x plus 1 times x minus 3. And so I want to multiply these factors. I'll keep for now the x plus 4 intact, and I'm going to multiply x plus 1 times x minus 3 to get to x squared minus 3x plus 1x minus 3. And I can do some combining. In my second expression, x squared, I'll combine the x's, minus 2x minus 3. And now I'm going to multiply x times all of the terms in the second expression, and 4 times all of the terms in the second expression. So x times x squared is x cubed. X times minus 2x is negative 2x squared. X times -3 is minus 3x. And then multiplying by 4. 4 times x squared is 4x squared. 4 times -2x is minus 8x. And 4 times -3 is minus 12. And notice how I've aligned these multiplications. I can now add, and I've aligned so that I'm adding down, I'm adding like terms. X cubed and x to the power of 2, I have two terms, -2x to the power of 2 plus 4x to the power of 2 gives me plus 2x squared. -3x, -8x minus 11x minus 12. And so this is our cubic. So I'll call this the function of x. And this is equal to x cubed plus 2x squared minus 11x minus 12. Now we're going to do some additional work with this cubic function, but as a side note, if I'm asked to calculate all cubics with these 3 zeros, then I can simply take the entire function and multiply by some factor that I'll, in this case, call a. So if I multiply all terms by the factor a, 1/2, 2, 10, whatever it might be, I'll have a multiple of this base cubic function, and the zeros will all be the same. In this case, I don't want that scalar component. I simply want to work with the function that I've derived, and we'll do some additional work with this cubic. Now let's work the other direction. Let's start with the function that we've created. Let's say we're given, instead of being given the zeros, we're given the function x cubed plus 2x squared minus 11x minus 12. And we're asked to find the zeros. Well, we can start by observing the constant term at the end, -12. We want to consider all of the factors of -12, and those are going to be 1 and 12, as well as 2 and 6, as well as 3 and 4. And in all cases, I could have positive or negative values. Now I know that when I multiply the constant terms of all of my factors, the result needs to end up as a negative 12. And of course I already know, looking at the left-hand side of the screen, what my zeros are. But again, let's assume I didn't start with the zeros. Instead, I started with the cubic, and I'm asked to calculate the zeros. I'm going to take into consideration all of these possibilities, and I'm going to look at a procedure to evaluate. Ideally, I won't have to evaluate all of these, but let's look at the concept of synthetic division to understand how we can evaluate the possible factors that we've identified for this function. I'm going to start by writing the coefficients. I'm going to start by writing the coefficients of the function. The coefficient of x cubed is 1, then positive 2, then negative 11, then negative 12. And I'm going to, on the left, I'm going to select which one of these factors I want to evaluate. Now, in this case, I want us to work with a factor that results in, or that we determine is, in fact, one of the zeros of the function. So we're going to cheat a little bit. Let's look over to the left. We know that negative 4, negative 1, and 3 are all the zeros of this function. So I'm going to choose negative 4. And again, normally I won't know ahead of time that negative 4 is going to work, so to speak. I'm evaluating negative 4. I'm going to put negative 4 into a box. And then I'm going to leave some space and draw a horizontal line. And now to begin my synthetic division process. First, I bring down my first coefficient of 1. And now what I want to do is I want to multiply the 0 that I've selected for evaluation, negative 4, times 1. That gives me negative 4, and that's going into the empty row, negative 4. Now, the math I'm going to do here is addition. 2 plus negative 4 gives me negative 2. And again, I'm going to multiply the 0 I'm evaluating, negative 4, times negative 2. That's going to give me a value of positive 8. And I place that under the negative 11. Again, performing addition. Negative 11 plus 8 is negative 3. And another multiplication. The 0 I'm evaluating of negative 4 times negative 3 is positive 12. And negative 12 plus 12 equals 0. Now it's that 0 that gives me the information that I'm looking for. The 0 tells me that negative 4 is a 0 of this function. Now, if I had calculated any number other than 0, I would know that the 0 I was evaluating was not, in fact, a 0. Again, we already knew the answer. We already knew negative 4 was a 0, but you won't be given that information in most cases. You need a way to evaluate the possible zeros, and we've identified 6, 1, 12, 2, 6, 3, 4. All of those times the negative sign is another 6. So we've identified 12 possible factors. We've just tested one, and as this final result is 0, we've confirmed that negative 4 is one of the zeros, which means x plus 4 is one of the factors of the cubic. I have another way I can evaluate the value negative 4 as a possible 0 for this cubic, and this is known as the factor theorem. And in the next video, we'll see how to apply the factor theorem, as well as another important concept, the remainder theorem, to the analysis of this cubic. I'll see you then.